Hello 3D printing friends. Today on the BV3D channel we're going to cover safe ways to test the Thermal Runaway Protection feature on 3D printers. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about cool 3D printer upgrades, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to see how to test the Thermal Runaway Protection feature of a 3D printer safely. Now, why test Thermal Runaway Protection? Well, the short answer is safety. This feature can help prevent 3D printer fires. Now let's talk a bit about the thermal safety features available on 3D printers. The printer uses thermistors to measure temperature. Thermistors are thermally variable resistors, electronic components whose resistance varies as a function of their temperature. So, by reading the resistance value, the printer can determine the temperature of a thermistor. Now, typically, the printer has a thermistor in the heater block on the hot end, and if it has a heated bed, there's one attached to the bed. Now, there are two kinds of thermal errors. There's a min-temp error and a thermal runaway error. A min-temp error is part of a basic test to see if the thermistor is even connected. So if a thermistor has failed in such a way that it doesn't return a value at all, or it's been unplugged from the mainboard, or its cable has a break in it, you will see a min-temp error. A thermal runaway error is one in which the printer is trying to get one of its heating elements to a desired set point, but it fails. A set point is the target temperature that it wants to reach or maintain, and it's either set in G-code when you're printing a file, or you can set it from the printer's control panel, such as when you're trying to unload or load filament or preheat the printer for printing. So imagine this scenario. The small screw securing the thermistor to the heater block at the nozzle has come unscrewed, and the thermistor is no longer being held in place in the heater block. It can't accurately report the temperature of the heater block, it can only report the temperature of the air in the room. Now the printer wants the heater block for the nozzle to be at 200 degrees C. And the printer reads the thermistor and sees the ambient room temperature, say 23 degrees C. So the printer applies power to the heater cartridge and monitors the temperature reported by the thermistor. The printer doesn't see the temperature of the heater block, it only sees the ambient room temperature. Without thermal runaway protection enabled, the printer will continue applying power to the heater cartridge, and it is not going to stop until that thermistor reads 200 degrees C. Now meanwhile, the heater cartridge is going way past that temperature. But the printer doesn't know that. It sees room temperature. But it wants to get to 200 degrees C come hell or high water, and it is not going to give up trying. So it keeps applying power to the heater cartridge. Now meanwhile, there's smoke pouring out of the hot end as whatever filament was in it is cooked off, and if there are any other plastic parts near it, they can start to melt or even catch fire. But with thermal runaway protection enabled, while the printer is applying power to the heater cartridge, if the temperature doesn't start moving toward the set point, or doesn't move toward it fast enough, the printer knows something is wrong. It will declare a thermal runaway condition and it will stop everything it's doing, which also means it'll cut power to the heater cartridge. And at that point, you'll need to reset the printer by removing and reapplying power. Now, thermal runaway protection doesn't just work at the beginning of a print job when the printer is trying to get up to temperature. That feature is constantly monitoring the heating element's temperatures, so if the thermistor gets pulled out of the hot end because a screw fell out and its cable snagged on a curled up part of a print, the printer detects that drop in temperature and sees that it can't keep the temperature at the set point. So again, after a few moments, the printer shuts down with a thermal runaway error. So how can you test your printer to see if it has thermal runaway protection enabled? Well, there are a couple of unsafe ways to test it. One is to remove the heater cartridge from the hot end, and then set the temperature to 200 degrees C and watch to see whether the heater cartridge starts glowing red hot or whether the printer shuts down. Another one is similar. Remove the thermistor from the heater block at the hot end, and again set the temperature to 200 degrees C. Now you won't be able to see if the heater cartridge is glowing, but you can monitor the hot end to see if it starts smoking or if the printer shuts down. But we're not going to do either one of those. We do not want to summon the fire gods. Now there are a couple of safer, less smoke-filled ways that we can test this feature that don't involve things getting fire-startingly hot. One of them is super easy, the other involves getting inside your printer, so we'll start with the easy way first. I call this one the USB power method. If your printer's mainboard can be powered by its USB port, you can use this method to test your printer. And here's how to find out if you can use this testing method. Plug in a USB power adapter, such as a cell phone power adapter, and turn the printer off. Connect a USB cable from that power adapter to the printer's USB port. If the screen lights up and the printer boots, you can use this method. So having determined that you can use this testing method, here's how to actually perform the test. With the printer's power switch turned off and a USB power adapter providing power to the main board, set the nozzle to 200 degrees C. Since the USB port can't provide enough power to move the stepper motors or operate the heaters, the nozzle temperature will remain at room temperature. This simulates the thermistor or heater cartridge being pulled out of the hot end. If this actually happened on a printer, the thermistor would no longer be able to provide the main board with an accurate temperature reading, and without thermal runaway protection enabled, the printer would keep the heater powered on, trying to reach that 200 degree set point. But if thermal runaway protection is enabled, once a short amount of time has elapsed without the temperature moving toward the set point, the printer will display a thermal protection error and shut down, requiring a reset. Now, if several minutes go by and the printer still hasn't complained or shut down, the most likely reason is that the printer doesn't have thermal runaway protection enabled. Now, if your printer's main board cannot be powered by its USB port, there is another safe way to test the thermal runaway feature, which I call the unplug the heater cartridge method. Now, if you're not comfortable opening your printer, loosening screw terminals, unplugging things, and then putting everything back together again, do not do this. If you are, though, here's how to do it. Oh, and you're doing this at your own risk. If something goes wrong and you break your printer, you've been warned. Okay, so first, turn off the printer. Then, access the printer's main board. Now, usually this involves removing a couple of screws and then removing a metal panel covering the printer's innards. The exact placement of wires for the heater cartridge varies by printer. Typically, what you're looking for is a pair of heavy-duty wires connected to screw terminals. On most main boards, you'll have 3 pairs of these. One pair is the power input for the board coming from the power supply. One pair is the power output for the heated bed, and one pair is the power output for the heater cartridge for the nozzle. Using this Creality board as an example, the power supply connects here, the bed connects here, and the heater cartridge connects here. Now again, the placement varies by printer, so it's on you to figure out which pair of wires is powering the heater cartridge. So loosen the screws securing the heater cartridge's wires in the terminal block, and then remove them. If you want to be extra careful with them, you can wrap the ends in electrical tape so that they don't short out against anything else inside the printer. With those wires disconnected, turn the printer on and set the nozzle to 200 degrees C. After a short amount of time has elapsed, without the temperature moving toward the set point, if thermal runaway protection is enabled, the printer will display a thermal protection error and shut down, requiring a reset. However, if several minutes have gone by and the printer still hasn't complained or shut down, well, again, the most likely reason is that the printer doesn't have thermal runaway protection enabled. So with the test completed, turn the printer off, reconnect the wires for the heater cartridge, and put the cover back on. The heater cartridge is not a polarized device, so it doesn't care which wire is connected to the positive terminal and which wire is connected to ground. I've used the USB power method to test my Soval SV01, which has thermal runaway protection enabled. I've also tested my Monoprice Maker Select Plus printers, which I have upgraded with the ADV i3++ firmware, and they have thermal runaway protection enabled too. And I've tested my Ender 3 Pro, which I've updated to the current Creality firmware compiled from source code. Now, the original firmware that it shipped with did not have thermal runaway protection enabled, but the current firmware does. And so my Ender 3 Pro now passes the test. If your Ender 3 or Ender 3 Pro doesn't pass the test, go watch the Installing a Bootloader and Updating to the Current Creality Firmware video linked in the description and get your printer updated to get this important safety feature enabled. So those are a couple of ways that you can test your printer to see if it has thermal runaway protection enabled. Test yours and let me know in the comments which printers you tested and which ones do and don't have thermal runaway protection enabled. And let me know if you're running the stock firmware or if you've updated it. Well, thanks for making it all the way to the end, and thanks for all of the likes, comments, and shares. Now don't forget to subscribe and click the bell so that you don't miss out on any cool 3D printing stuff. If you liked this episode, give it a thumbs up. If not, give it a thumbs down. But either way, please share your thoughts down in the comments. And if you like the content that I'm producing and you want to help out, check out the description for ways you can do that. Shopping using the Amazon affiliate link really helps no matter what you're buying, and heck, even just subscribing is a great way to support the channel and help keep me making these videos for you. Well, now that I'm more confident in my printer's thermal safety features, I'm going to go print something cool. You do the same, and I'll see you next time.